Hello, this is another series of our solutions to past examination questions, and we are looking at the topic of quadratics and pure mathematics 1 of Cambridge International AS and A level. Now, today's paper is of the code 9709/11, and it was taken November 2023. And this is pure mathematics 1. And as I'd said, it is advanced subsidiary and advanced level paper of Cambridge Assessment International Education. Now, the question of interest today is question 9. Question 9 is where we get the question to look at today. So question 9 reads, express 4x squared minus 12x plus 13 in the form 2x plus a squared plus b, where a and b are constants. So in other words, if you look at this, there's a compartment of this, so that this bit here forms a perfect square. So it means that this one itself is not a perfect square. So by having to write 13 in a different form, then we are able to come up with this. So that's 2 marks. The function f is defined by fx is equal to 4x squared minus 12x plus 13 for x lying between p and q, where p and q are constants. The function g is defined by g of x is equal to 3x plus 1 for x is less than 8, meaning x is approaching 8 but never touching 8. Given that it is possible to form the composite function gf, find the least possible value of p and the greatest possible value of q. So that is part B. Part C, find an expression for g of f of x. One mark. Then part D, the function h is defined by h of x is equal to 4x squared minus 12x plus 13 for x is less than 0. For x is less than 0, this is the limit. Find an expression for h inverse of x. That is 3 marks. So that's the question of concern today. And straight away, we consider the solution.
Now the solution continues as follows. We are given express 4x squared minus 12x plus 13 in the form 2x plus a squared plus b, where a and b are constants. For us to be asked to express it in this form, it means that this particular bit, this is a perfect square and this is not. And so we seek to write this in a manner that we make part of it a perfect square and remain with another one. Okay, the procedure is as follows. We take half of this, which is minus 6, using the concept of computing it square. So we say minus 6 squared gives me 36. Now, 36, I now come here to 18, 2, 9, 3, 3, 3, 1. So 4 times 9. That's 4 times 9. That's 4 plus 9. So I'll be having 4x squared minus 12x plus 9 plus 4 plus 4. Well, one would have decided to put 4 here, but now we see for convenience, that's why we put 9. So having 9 will give us a perfect square. So this is a perfect square, and we have a 4. So if it's a perfect square, then we can factorize it further by saying 4x squared. So we look for two numbers whose product is 36 and sum is 12. Product is 36 and sum is 12. That is 6 and 6. So that is first minus 6x plus 9. That's this part alone. And that will give me 2x into 2x minus 3. Here I have minus 3 into 2x minus 3. So it means I end up with 2x minus 3 squared to be this part. Then I say plus 4, plus 4, plus 4. Therefore, my A is minus 3, which is this, and B is 4. So those are the values of A and B. The function f is defined by f of x, which is f of x is equal to f of x is equal to 4x squared minus 12x plus 13 for x lying between P and Q, for x lying between P and Q. Those are the limits, the lower limit and the upper limit of x, where P and Q are constants. The function b is defined by g of x is equal to 3x plus 1, and for x less than 8, meaning the straight line 3x plus 1 approaches 8 but does not touch it. Then we find the least possible value of P and the greatest possible value of Q. Now we'll have to restrict the range of this conditioned to this. So we'll say 4x squared minus 12x plus 13 is less than 8. But we know this part, we know we can write this as a perfect square. So we say 4x squared we just say 2x minus 3 squared plus 4 is less than 8. That's what we have. And so it means that 2x minus 3 squared is less than 4. But we know this, we know expansion of this. When we expand this, we end up with 4x squared minus 12x plus 9 is now less than 4. We can then write this as 4x squared minus 12x plus 5 is less than 0. It's less than 0 as such. So we look for two values whose product is 20 and sum is negative 12. Those two values have to be negative 2 and 10 4x squared minus 2x minus 10x plus 5 is less than 0. Factorize 2x. I will have 2x minus 1. Then here I have minus 5 into 2x minus 1 is less than 0. That implies that it's either 2x minus 5 or 2x minus 1 is less than 0. So if I take this part, it will be 2x minus 5 is less than 0. That should imply that x is less than 5 omega, which is 2.5. If I take this, 2x minus 1 less than 0 should imply that x is less than half. Therefore, the least possible value is half, and the greatest possible value is 2.5. It's 2.5 as such. Then part C, this was part A, this is A, this is B, now we're in C. Find an expression for g f of x. G f of x. F of x is this, but now we need g of f of x. So we say g into this 4x squared minus 12x plus 13, like that, implying that g x, which is this, will now be, don't write that. The important figure we have is that if this is the function f of x as we have put it, then, and this is the function g of x. So it means that wherever we have this x, we will put this. So it implies that g f of x will be given by 3 into 4x squared minus 12x plus 13 plus 1, which is equal to 12x squared minus 36x plus 39 plus 1, which is equal to 12x squared minus 36x plus 40. So that is the answer to part C. Part D. Part D, the function h is defined by h of x is equal to 4x squared minus 12x plus 13, where x is less than 0. find an expression that inverse of the function. So this is what we want, and we start by saying that y is equal to 2x minus 3 squared plus 4. This should imply, because the whole of this is this, so that should imply that 2x minus 3 squared is equal to y minus 4. Y minus 4. So get the square of both ends. It will be 2x minus 3 is equal to root of y minus 4. This is going to be positive or negative. Positive or negative. Positive or negative. So that's that. And then this should mean that 2x is equal to 3 plus or minus root of y minus 4. Root of y minus 4. So x is equal to 3 over 2 plus or minus root of y minus 4 all over 2. Therefore, h of x inverse will be 3 over 2 because x is supposed to be less than 0, so we don't add. So we take 3 over 2 minus 3 over 2 minus root of x, where there's y we put x, minus 4 all over 2. And that's the answer to that last part. So that wraps up the solution to that particular question. And be keen to revise composite functions and quadratics, because this is composite functions blended into quadratics. So if you like the videos, like, comment, and subscribe. See you in the next video.